Okay, I can't stand it when I can't do. Sorry, I made you go through all that. All right, we're back. Now then, let's figure out. They're just messing with us, trying to get. We need to figure out what this angle is. Okay. Once we figure out what this angle is, then that's the same as the angle of incidence. Okay. Because why? Remember when back in 8th or 9th grade geometry when you thought you'd never use alternate interior angles in your life? Well, here you are. So if we take the inverse tangent of 13.4 over 15, I'm just going to work this out. And we need to find out what N1 is if we know that this is with air. So we know that N2 is 1.00. All right, let me write the things down. And we will go to town on this. N2 is equal to 1.00. N1 we do not know. Okay. But we've got to find that angle of incidence, which isn't hard. 13.4 centimeters and 15 centimeters. Cool. We got this. So here we go. Here's what I've got so far. We need to find N2 because it's critical angle going off here. All right. And N1 we don't know. Theta we don't know, but we know that theta is equal to this, which comes out to be theta is equal to the inverse tangent of opposite over adjacent 13.4 divided by 15. So my angle of incidence divided by 15 is equal to 41.7. Let's call it 41.8. Theta is equal to 41.8 degrees. All right. And that's my critical angle. So theta C, the sine of the critical angle, is equal to, now remember, N2 has to be less than N1, is equal to 1.00 over N1. So N1 is equal to 1 divided by the sine of 41.8. Ooh, I'm proud of myself for being able to come up with this. So 1 divided by the sine of 41.8. 1.5. So it's some kind of quartz. It's some kind of quartz or glass. That's what that is. Let's see if we're right. Oh, I didn't want to hit Firefox. Why would I want? Why would anybody want to use? What is the minimum index refraction of the liquid? I don't think it's a liquid. I think it's something else. It's one. I got 1.5. Yes. If you assume that what is its likely identification? I think it's plexiglass. I told you it's some kind of crystal. I'm gonna go with. Oh no, let's go with benzene. Oh, it is a fluid. I'm gonna go with benzene. Hey, there you go. So that's the way you do science. So that's kind of fun. And then let's take a look at this. Consider, we just did this for the most part. Consider light interface between water. Light interface between water and ice. Okay. Solids. Ice baby. 1.309. I've got my granddaughters saying that when they went ice with their water or something. They went ice baby. Anyway, yes, we are getting slap happy here. All right, water is 1.33. So notice, ice has less of an index of refraction. It's a little bit less. All right, so what is the minimum angle in degrees in which you still get total internal reflection with this surface? This might be kind of tricky because, boy, they're so close. We're going to have to let our calculator really run. So it's got to go from water into the ice. Okay, so the sine, so this one would be, so the water into ice, and this will be a good place for me to quit for the day. I'm burning fat I don't have right now. So anyway, and it's fraught with peril because I want to go back to, all right, so N1 is equal to 1.333. Got to carry it out to 4 sig figs. N2 of ice is equal to 1.309. So therefore, the sine of the critical angle, is equal to N2 over N1. Now it's going to be real close to 1, but not quite. It's going to be real close to 1, but not quite. So I'm going to take 1.309 divided by 1.333 and get that. Let's take the inverse of that angle. Inverse sine of, plug that answer in. Woo! Critical angle is 79 degrees. So anything inside of 79 degrees is going to get out. Some of it will get reflected back in, but a lot of it's going to get out. That's why ice looks clear on the edges and all that kind of stuff. Plus, you chemists know better than I do about all the other properties that it's got. Okay? If that's right, this late in the afternoon, I'm going to hoot and holler. I'm going to go 79.1 since we had to go out to 4 sig figs just to get this to work. I'm on a roll. Why stop now? Why stop now? All right. We will stop now. And that is good. We're good. Oh, I forget.